seen over and over that one of the most reliable ways to get a high-performance machine learning system is to take a low-bias learning algorithm and to train it on a massive training set. But where do you get so much training data from? Turns out that in machine learning, there's a fascinating idea called artificial data synthesis. This doesn't apply to every single problem, and to apply to a specific problem often takes some thought and innovation and insight. But if this idea applies to your machine learning problem, it can sometimes be an easy way to get a huge training set to give to your learning algorithm. The idea of artificial data synthesis comprises of two main variations. The first is if we're essentially creating data from whole cloth, so creating new data from scratch. And the second is if we already have a small labeled training set and we somehow amplify that training set or use a small training set to turn that into a larger training set. And in this video, we'll go over both of those ideas. To talk about the artificial data synthesis idea, let's use the character recognition portion of the photo OCR pipeline, where we want to take as input an image and recognize what character it is. If we go out and collect a large labeled dataset, here's what the dataset would look like. For this particular example, I've chosen a square aspect ratio, so we're taking square image patches, and the goal is to take an image patch and recognize the character in the middle of that image patch. And for the sake of simplicity, I'm going to treat these images as grayscale images rather than color images. It turns out that using color doesn't seem to help that much for this particular problem. So given this image patch, we'd like to recognize that that's a T. Given this image patch, we'd like to recognize that that's an S. Given that image patch, we'd like to recognize that that's an I, and so on. So all of these are examples of raw images. How can we come up with a much larger training set? Modern computers often have a huge font library, and if you use a word processing software, depending on what word processor you use, it might have all of these fonts and many, many more already stored inside. And in fact, if you go to different websites, there are, again, huge free font libraries on the internet where you can download many, many different types of fonts, hundreds or perhaps thousands of different fonts. So if you want more training examples, one thing you can do is just take characters from different fonts and paste these characters against different random backgrounds. So you might take this alphabet C and paste that C against a random background. And if you do that, you now have a training example of an image of the character C. So after some amount of work, it is a little bit of work to synthesize realistic looking data, but after some amount of work, you can get a synthetic training set like that. Every image shown on the right was actually a synthesized image where you take a font from maybe a random font downloaded off the web, and you paste an image of one character or a few characters from that font against a sort of random background image, and then apply maybe little blurring operators, maybe little affine distortions, affine meaning just a shearing and scaling and little rotation operations. And if you do that, you get a synthetic training set like the one shown here. And this is work, right? It takes thought and work in order to make the synthetic data look realistic. And if you do a sloppy job in terms of how you create the synthetic data, then it actually won't work well. But if you look at these, the synthetic data actually looks remarkably similar to the raw data. And so by using synthetic data, you have essentially an unlimited supply of training examples for artificial data synthesis. And so if you use this sort of synthetic data, you have essentially an unlimited supply of label data to train a supervised learning algorithm for the character recognition problem. So this is an example of artificial data synthesis where you're basically creating new data from scratch. You're just generating brand new images from scratch. The other main approach to artificial data synthesis is where you take examples that you currently have. So where you take a raw example, maybe from a raw image, and you create additional data so as to amplify your training set. So here's an image of a character A from a raw image, not a synthesized image. And I've overlaid this with the grid lines just for the purpose of illustration. It shouldn't actually have these grid lines, of course. But what you can do is then take this alphabet A, or take this image, and introduce artificial warpings or artificial distortions into the image so that you can take the image A and turn that into 16 new examples. So in this way, you can take maybe a small label training set and amplify your training set to sort of suddenly get a lot more examples out of it. Again, in order to do this for a particular application, it does take thought and it does take insight to figure out what are reasonable sets of distortions or what are reasonable ways to amplify or to multiply your training set. And for the specific example of character recognition, introducing these warping seems like a natural choice, but for a different machine learning application, there may be different distortions that might make more sense. Let me just show one example from a totally different domain of speech recognition. So in speech recognition, let's say you have audio clips and you want to learn from the audio clip to recognize what were the words spoken in that clip. So let's say you have one labeled training example. So let's say you have one labeled training example of someone saying a few specific words. So let's play that audio clip here.
0, 1, 2, 3, 4, 5.
Alright, so there's some counting from 0 to 5, and so you want to try to apply a learning algorithm to try to recognize the words said in that. So how can we amplify the data set? Well, one thing we can do is introduce additional audio distortions into the data set. So here I'm going to add background sounds to simulate a bad cell phone connection. When you hear beeping sounds, that's actually part of the audio track. There's nothing wrong with speakers, but let me play this now.
0, 1, 2, 3, 4, 5.
Right, so you can listen to that sort of audio clip and recognize the sounds. That seems like another useful training example to have. Here's another example, noisy background.
0, 1, 2, 3, 4, 5.
You have cars driving past, people walking in the background. Here's another one. And so taking the original clean audio clip, so taking the clean audio of someone saying 0, 1, 2, 3, 4, 5, we can then automatically synthesize these additional training examples and thus amplify one training example into maybe 4 different training examples. So let me just play this final example as well.
0, 1, 2, 3, 4, 5.
Right, so by taking just one labeled example, we had to go to the effort to collect just one labeled example of the 0, 1, 2, 3, 4, 5. And by synthesizing additional distortions, by introducing different background sounds, we've now multiplied this one example into many more examples without much work, by just automatically adding these different background sounds to the clean audio clip. Just one word of warning about synthesizing data by introducing distortions. If you're trying to do this yourself, the distortions you introduce should be representative of the sorts of noises or distortion that you might see in the test set. So for the character recognition example, the warpings we introduce are actually kind of reasonable, because an image A that looks like that could be an image that we could actually see in the test set. This looks like a fatter A. And if that image on the upper right, that could be an image that we could imagine seeing. And for audio, well, we do want to recognize speech even against a bad cell phone connection and against different types of background noise. And so for the audio, we're again synthesizing examples that are actually representative of the sorts of examples that we want to classify or want to recognize correctly. In contrast, usually it does not help to add purely random or meaningless noise to your data. Not sure you can see this, but what we've done here is taken the image, and for each pixel in each of these 4 images, just added some random Gaussian noise to each pixel. So each pixel is the pixel brightness, and if you just add some, maybe Gaussian random noise to each pixel, just sort of totally meaningless noise, right? And so unless you're expecting to see these sorts of pixel-wise noise in your test set, this sort of purely random meaningless noise is less likely to be useful. But the process of artificial data synthesis, it is, a little bit of an art as well, and sometimes you just have to try it and see if it works. But if you're trying to decide what sorts of distortions to add, do think about what are the meaningful distortions you might add that will cause you to generate additional training examples that are at least somewhat representative of the sorts of images you expect to see in your test set. Finally, to wrap up this video, just want to say a couple words more about this idea of getting lots of data via artificial data synthesis. As always, before expending a lot of effort, figuring out how to create artificial training examples, it's often good practice to make sure that you really have a low bias classifier, and that having a lot more training data will really help. And the standard way to do this is to plot the learning curves to make sure that you have a low bias or high variance classifier. Or if you don't have a low bias classifier, one other thing that's worth trying is to keep increasing the number of features that your classifier has, increasing the number of hidden units in your neural network, say, until you actually have a low bias classifier. And only then should you put the effort into creating a large artificial training set. So what you really want to avoid is to spend a whole week or spend a few months figuring out how to get a great artificially synthesized data set, only to realize afterward that your learning algorithms and performance doesn't improve that much, even when you give it a huge training set. So that's sort of our usual advice of testing that you really can make use of a large training set before spending a lot of effort going out to get that large training set. Second is, when I'm working on the machine learning problems, one question I often ask the team I'm working with, that I often ask my students, which is, how much work would it be to get 10 times as much data as we currently have? When I face a new machine learning application, very often I'll actually sit down with the team and I'll ask exactly this question. I've asked this question over and over and over. And I've been very surprised how often this answer has been that, it's really not that hard. It's maybe a few days of work at most to get 10 times as much data as we currently have for a machine learning application. And very often, if you can get 10 times as much data, there will be a way to make your algorithm do much better. So, if you ever join a product team working on some machine learning application product, this is a very good question to ask yourself and ask the team. And don't be too surprised if after a few minutes of brainstorming, if your team comes up with a way to get literally 10 times as much data, in which case I think you would be a hero to that product team, because with 10 times as much data, I think you might really get much better performance just from learning from so much data. So there are several ways to try to get a lot more data, and in this video we focus mainly on the idea of artificial data synthesis, and that comprised both the ideas of generating data from scratch using the random fonts and so on, as well as the second idea of taking an existing example and introducing distortions to amplify to enlarge the training set. A couple other examples of ways to get a lot more data are to collect the data or to label it yourself. So one useful calculation that I often do is ask, how many minutes, how many hours does it take to get a certain number of examples? So I should sit down and figure out, suppose it takes me 10 seconds to label one example. Then, and suppose that for our application, currently we have 1,000 labeled examples. So 10x as much of that would be if m would equal to 10,000. Right, so a second way to get a lot of data is to just collect the data and label it yourself. So what I mean by this is I will often sit down and do a calculation to figure out how much time, like just how many hours would it take, how many hours or how many days would it take for me or for someone else to just sit down and collect 10 times as much data as we have currently by collecting the data ourselves and labeling ourselves. So for example, let's say that for a machine learning application, currently we have 1,000 examples, so m equals 1,000. Then what we'll do is sit down and ask, well, how long does it take me really to collect and label one example? And sometimes maybe it'll take you, 10 seconds to label one new example. And so if I want 10x as many examples, I do a calculation. If it takes me 10 seconds to get one training example, if I want to get 10 times as much data, then I need 10,000 examples. So I do the calculation. How long is it going to take me to manually label 10,000 examples if it takes me 10 seconds to label one example? So when you do this calculation, often I've seen many teams be surprised at how little work, sometimes a few days of work, sometimes a small number of weeks of work, but I've seen many teams be very surprised at sometimes how little work it could be to just get a lot more data and let that be a way to give your learning algorithm a huge boost in performance. And as I said earlier, sometimes if you've just managed to do this, you will be a hero in whatever product development or whatever team you're working on, because this can be a great way to get much better performance. Third and finally, one sometimes good way to get a lot of data is to use what's now called crowdsourcing. So today there are a few websites or a few services that allow you to hire people on the web to fairly inexpensively label large training sets for you. So this idea of crowdsourcing or of crowdsourced data labeling is something that has its own sort of entirely academic literature. It has some of its own complications and so on pertaining to labeler reliability. If you have hundreds or thousands of labelers around the world working fairly inexpensively to help label data for you. And the lecturer mentioned this as one alternative as well. And probably Amazon Mechanical Turk system is probably the most popular crowdsourcing option right now. But this is often, quite a bit of work to get to work if you want to get very high quality labels. But it's sometimes an option worth considering as well. If you want to try to hire many people to fairly inexpensively on the web label large amounts of data for you. So in this video, we talked about the idea of artificial data synthesis, of either creating new data from scratch, like using the random fonts in our example, or by amplifying an existing training set by taking existing label examples and introducing distortions to it to sort of create extra label examples. And finally, one thing that I hope you remember from this video is this idea of, if you're facing a machine learning problem, it's often worth doing two things. One, just sanity check with learning curves that having more data would help. And second, assuming that that's the case, I would often sit down and ask yourself seriously, what would it take to get 10 times as much training data as you currently have? And not always, but sometimes you may be surprised by how easy that turns out to be. Maybe a few days or a few weeks of work, and that can be a great way to give your learning algorithm a huge boost in performance.